Okay, this video is about section 11.3, testing the difference between two means. Sorry. Okay, so we're gonna test the difference between two means. Let's read it. And these are independent samples. A research suggests that female nurses earn less than male nurses. A survey of 16 male nurses and 20 female nurses report these data. Is there enough evidence to support the claim that female nurses earn less than male nurses? Use 1% level of significance. Assume the data are from normally distributed population and that the population standard deviation are not equal. Means when it comes to using pooled, guys, you just select no. This is what it means when it says population standard deviation are not equal or population variances are not equal. First of all, we need to state the null and the alternative hypotheses. So let's do that. So we're testing the claim that mu1, 1 represents the female and 2 represents males. Mu1 is less than mu2. That's the claim. And as you know, the null hypothesis is always a statement of equality. So mu1 equals mu2. Okay, I'm going to show you how to use the calculator first. We're going to be using a two-sample t-test. Why T not Z? Because he did not give me population standard deviation. Most of the times he will give you S1, S2, but not sigma 1 and sigma 2. In this case, you must use the T distribution, which is the t-test. So let me show you the calculator. All right, so this is how you do it. You go to Stat, Tests, two-sample t-test. Enter. Data, I don't have data, I have the summary. X1 bar, it's for female, so it's 23,750. Enter. Standard deviation is 250. And how many in the sample? We have 20. Then we go to the male nurses. The average salary is 23,900. Enter. S2 is 300. And the sample size was 16. And now, guys, you need to choose the alternative hypothesis sign, which is less than. And it's a blinking that's not selected. You must hit enter. If you don't hit enter, it will be at greater than. Pooled. When he says assume population standard deviation are not equal, non-pooled, so it's a no. And if you want, guys, to do a draw, you can see the p-value in action. It should be on the left because this is a left tail test. So the test statistic is what? Negative 1.683. And the p-value is 0.0598. And remember, you can also do it this way, guys. You can go to Stat, Tests, do sample t-test number 4, press enter. You can do everything, and instead of draw, you can do calculate. And here's the test statistics. So it's negative 1.604. Negative 1.604. I made a mistake reading it from the other one. And the p-value is 0.0598. What did I say earlier? Yeah, 0.0598. All right. So let's go back to our document and enter the test statistic. It's T0 equal negative 1.604. P-value is 0.0598. And what's alpha, guys? Is 1%. That's bigger than 1%. Bigger than 0.081. This is how you justify your answer. So what's your decision? Fail to reject HO. Conclusion. If you fail to reject HO, you cannot support the claim. There is not enough evidence at the 1% alpha level of significance, level of significance to support the claim that female nurses earn, that male nurses or female nurses earn less than male nurses. Let me show you how to do StatCrunch here. Okay, so I'm gonna call StatCrunch stat T stat. You have to use T here, not Z. We're using T. To sample with summary, and we're gonna enter the information. The first sample is 23,750 for the mean. Sample standard deviation was 250. Sample size was 20. That's for female. Now for sample 2 for male, 23,900. 300 for the standard deviation. 16. And we said it's non-pooled, so you don't select this one. You only select it if it is pooled. And when do you select it is pooled? If it says population variances are equal. Here it says population variances are not equal. And what are we testing? mu1 less than mu2, so you have to choose the sign less, guys. And if you want to do a p-value plot, you can do that. I'll show you now what's going to happen. Hit compute, and let's bring this to the main screen to see it, so you can see. Look, guys, this is the p-value, negative 1.604. The test statistic t0, t sub 0, and 0.0598 is the p-value. And look, this is the p-value, the shading of the p-value. Okay, so this is how you do it using StatCrunch. Okay, guys, here's another question from section 11.3. And in this question, you are given the population standard deviations, which is not really usually the case. Most of the time, you are given sample standard deviation, but I'm just going to show you how to deal with it if he gives you sigma 1 and sigma 2 instead of S1 and S2. And what do we call sigma 1 and sigma 2? Population standard deviation. Two brands of cigarettes are selected and their nicotine content is compared. The data are shown below. At alpha equal 5%, is there convincing evidence that the mean amount of nicotine differs? What does differ, guys, means? It means not equal to between the two brands. Use alpha equal 5%. So we're going to write down the null and the alternative hypothesis, and then we can proceed to the test. Okay. So for H1, guys, it will be mu1 not equal to mu2. This is the claim. That's what he's saying, differs. And HO, as you know, it's a statement always of equality. So mu1 equals mu2. Here, we're not going to use a t-test because he gave me sigma 1 and sigma 2. I cannot use a t-test. I must use a z-test. And the name of the test is called two-sample because we're using two-sample z-test. So it will be two-sample z. So it's a two-sample z-test. Let me show you how to do that on the calculator. So go to stat, tests, two-sample z-test. Number 3, press enter. It's summary. Okay. He's asking for sigma 1, which is 5.1. Now he's going to ask for sigma 2, which is 4.9. Then the sample mean, 28.6. Amount of nicotine average. N1, we have a sample of size 30 for the first brand. X2 bar is 32.9. N2 is 40. And what we're testing, what's the alternative sign, guys? It's not equal to. And now if we go to draw, if you like. Okay. So the test statistic Z is negative 3.55. And the p-value is 4e minus 4. Let's write it down and then I'll explain that to you. So Z is negative 3.55 and p-value is, show you again, it was 4e minus 4, means almost 0. You didn't see any shade in there, it's almost 0. Okay, 4e minus 4 means, don't ignore the e, the p-value is a number between 0 and 1. It means 4 times 10 raised to the power of negative 4, which means that you have to move the decimal point 4 digits to the left, so it will be 0.0004, which is of course less than alpha, so you reject HO this time. And if we reject HO, what's the conclusion? We support the claim. There is enough evidence at the 5% level of significance to support or to conclude. He says, can it be concluded? Or is there convincing evidence? Yeah, to support the claim that the mean amount of nicotine differs between the two brands. You do it, that's exactly what you need to do. So that let's show you now how to use StatCrunch for this one. So you go to stat, not T statistics, it's Z stats, to sample with summary. Mean from the first sample is 28.6. Standard deviation is 5.1. Sample size, as we said, we had 30. From the second sample is what, 32.9. Standard deviation was 4.9. And sample size was 40. And we need to test that mu1 is different from mu2, so you already have the difference sign. And if you guys want to plot the p-value, you can do that, but you're not going to see anything. Compute, it usually goes toward the right, so I'm going to show it to you right here. Look guys, that's what exactly I got on the calculator, negative 3.55, and look, this is the p-value. The p-value is low, then HO must go. And you want to see a sketch of the p-value diagram, you're not going to see much of the p-value. See, it's almost 0. That's why you don't see much in there. So this is the end of section 11.3.